Alright, let's look at the ODE Practice Exam 4, problem number 27. Alright, so let's use Laplace transforms to solve this initial value problem. Alright, so first I'm going to just take the Laplace transform of the equation. Alright, so take the Laplace transform. Alright, so you're going to get, let's see, s squared, capital X of s minus s times x of 0 minus x prime of 0, right? Plus 4 times Laplace transform x is capital X of s, right? Then this is equal to, right, Laplace transform of e to the negative 3t would be 1 over s minus negative 3. So it's going to be s plus 3. Right? So we got that. Then we plug in what we already know. So x of 0 is 1. So this is equal to 1. And this is 0. So this guy is 0. So I'm going to just cancel it out. So this is 0. Alright, so let's collect the x of s terms. So you have 1 here. Oops. You have 1 here, and here's another one. So collect those two terms. Write it as so we have a s squared plus 4 capital X of s, right? And then I put this negative s, so I'm gonna add s to both sides. So I'm gonna add s to both sides. So you get 1 over s plus 3, right? And plus s, right? Then we can just take the common denominator. So I'm going to multiply s and top and bottom by s plus 3 and s plus 3. That way we can just combine them. So the denominator, common denominator would be s plus 3. And then you have s times s is s squared. And s times 3 is 3s. And then you have a plus 1, right? Then we can isolate the capital X of s by dividing by quantity s squared plus 4. All right, so capital X of s is equal to, so we get s squared plus 3s plus 1. All over x plus s as 3 times s plus x squared plus 4. Alright, then what we need to do is we need to do a partial fraction decomposition on this guy. So let's do that on the side here. Alright, so you have s squared plus 3s plus 1 over, alright, so you have s plus 3 and s squared plus 4, and this can be decomposed into, alright, so you have s plus 3, so you have a constant on top, and plus s squared plus 4. Then you would have bs plus c. So you have a linear term on top. All right. Then I'm gonna put them back together. So of course you get the same denominator as before, s squared plus 4. All right. So you multiply a by s squared plus 4. So you get a s squared plus 4a, and then plus I'm going to multiply bs plus c by s plus 3. So I'm going to distribute s, so you have a bs squared plus cs, and distributing 3, so you're going to have 3bs plus 3c. Alright, so then what we need to do is we just need to make sure that the numerators matches up. Alright, so let's do that. So we're going to match this numerator to that numerator. Right, oh shoot. Right, so that numerator there. Right, I'm keep on doing the same thing. Right, that numerator there. Alright, so I'm going to just collect the like terms. So there's a s squared term. So here's one, and here's another one. So I'm going to get a plus b s squared. Right. Then s term would be there's a cs and there's a 3bs. So we're going to get c plus 3b s, right? Then the constant term would be 4a and 3c. So we're going to have plus 4a plus 3c, right? So this is going to be equal to original numerator, so s squared plus 3s plus 1, right? So comparing the coefficient, so a coefficient of s squared is 1, so a plus b must be 1. And the coefficient of s would be 3, so c plus 3b is equal to 3. And the constant term is 1, so 4a plus 3c is 1. Alright, so let's try to solve this system of equations. So I'm going to just write down those equations. Alright, so I have a plus b equals 1, and c plus 3b equals 3. And 4a plus 3c equals 1. Alright, so let's try to look at the first two and try to get rid of, maybe try to get rid of b, right? So I'm going to multiply by 3. You get the 3a plus 3b is equal to 3. Alright, so you have a c plus 3, I'm just going to copy that one, 3b is equal to 3. So we can just do a subtraction, right? And that will give us 3a minus c, and 3b minus, so they cancel out, so it's going to be 0, right? So we got one equation there. Right, then I'm going to multiply this guy by 3 again. So you're going to get the 9a minus 3c is equal to still 0. Right, then we can just do addition here. So that way you have a 13a is equal to cancel out is equal to 1. Right, then we can just divide through by 13. To get the a value, which is 1 over 13. Alright, so from here, c value can be found as c is equal to 3a, and which means that 3 times 1 over 13, so 3 over 13. Alright, since a plus b is equal to 1, so b is going to be equal to 1 minus a. Right? So it's 1 minus 1 over 13 is 12 over 13. Right? So it took us a while, but we found the A, B, and C. Right? So we have, so this guy is now written as, right? A is so everyone has a 13 on the bottom. So maybe I'll put 1 over 13 outside. Right? So a is 1 over 13. So I'm going to put the 1 over s plus 3, right? Then let's see, so b is 12 over 13. So it's going to be plus 12s. And the c would be 3 over 13. So plus 3 over s squared plus 4, right? And then I'm going to do a little bit of tweaking so that we can find the inverse Laplace transform. So I'm going to clean it up as this. Capital X of S is equal to, right, 13 is outside. Right, this one, I'm going to write it as 1 over S minus negative 3, right? So this one, I'm going to write this guy as, right, 12 outside. Then we have S over S squared plus, I'm going to write 4 as 2 squared, right? And then here plus, right, I'm going to put 3 in front, right? Then we have, let's see, I would like to have 2. So I'm going to put 2 here. And I'm going to put 2 on the bottom so we don't change anything. Then you have s squared plus 2 squared, right? All right, then we can find the inverse Laplace transform. So we take the inverse Laplace transform to get x of t, right? So this is going to be 1 over 13, right? Then this is going to be just e to the negative 3t. And this is going to be 12 times. So this is going to be a cosine of 2t, right? Plus 3 over 2. This is going to be sine of 2t, right? So that is the solution that we are looking for. So that is the solution of initial value problem. All right, that's it. I hope that this was clear.